In this video, we will go over the RAM set-top box report feature. First, let's launch report generation from the smartphone, and then talk about the diagnostics function in more detail. We should keep in mind that we can generate either the current report or the baseline report. The baseline report can be used in the future to compare against, even after a long while, and provide some insights into the trends for some technical parameters. The algorithm for report generation and for diagnostics is fairly flexible and customizable, and can be adjusted according to the client requirements. Let us clarify upfront that this function is targeted for professionals and may be very useful for average users. However, both the operator and the users can enjoy its benefits. For example, can a user access the quality of capable work using the Spectre? No. But can we understand the root cause and send a notification with instructions to the user? Yes, indeed. Can a user figure out that the antenna or its mount is damaged or not properly fixed using the angle values? No. But a warning message about that issue can be sent to a user via text notification. All that means that we can create a diagnostic system and guides with instructions for users to fix issues on their own, using the report. Moreover, using the initial report generated upon the successful completion of the antenna setup and subsequent reports over time will let us collect the statistical data and the trends and dynamics of any concrete user configuration. In this video, we'll go over the part of report and diagnostics that doesn't involve Spectre. We will look at the Spectre-related part in a separate video. Also, we won't configure diagnostics in our version. Operators can develop their own diagnostic systems and guides with instructions for self-debugging various issues, since all reports can also be forwarded to operators. So, let's begin. The manufacturer and the model of the antenna. The operator can collect the data for the antennas being used in a region. Some users will name it correctly. Power adapter mode. With this metric, we can detect a fault in the power adapter or that a wrong power adapter is used. Output voltage. We will generate the baseline report before the first scan, and will use it for a comparison of future measurements. If the current drifts from the baseline value, it might point to a potential short circuit in the cable. The current spikes, cable damage, zero current, faulty converter elements, insignificant increase or a decrease of current. The antenna angles, static and dynamic, help to assess the quality of antenna stability. Also, it lets evaluating the condition of the antenna mount, meaning it might prevent the antenna collapse due to an unstable mount. Also, it lets accessing poor signal due to strong winds and in combination with other parameters to detect bad weather. RSSI is used to evaluate the signal strength and the quality of cable work. Next, we will evaluate the LNB frequency stability, looking at the difference between the expected and actual frequencies of the transponder. If it is larger than 2 MHz, then this item will turn red. The carrier-to-noise ratio, operating as SNR or SN, is a measure of the received carrier strength related to the strength of the received noise. Link margin is one of the key parameters indicating the signals are replies for each frequency, including bad weather. Usually, link margin is considered good when it is over 6 dB, medium when it is in range from 3 to 6, and poor when it is 3 dB or less. This parameter is also a key to understanding whether a customer will call the support service regarding the poor signal. So the low link margin can really be used as a trigger for a diagnostics run. SNR and modulation are used for a link margin calculation. Transpondatory lock error. If we see the signal but cannot lock it, it means something went wrong and we need to investigate further. PORI is used to run diagnostics when some packets are missing. In the next video, we will look at the SPECTRE. It allows to discover the most amount of problems. It is used for understanding the types of attenuation and distortions, shows the overlap of GSM signal and other interferences in the ranges from 950 to 2150 MHz and from 10 to 13 GHz. Also, SPECTRE helps to figure out the cause for a PORI signal. In case of skewed antenna, there are disperses, meaning that it might pick up signals from several satellites. In case of a cable with different impedance, mismatch and standing wave. In case of watering the cable, impedance varying in time and the problems of coordination cable system circuits. So, who will benefit the most from the report? Mainly operators, as well as the contractors that service the antenna installations. The management of these companies will always be confident that the service is up to a good quality and that many potential problems with customers can be avoided in the future. Also, each installation service from any technician will be verified by an act with a detailed report. Arguably, call centers will gain the most benefits from the reports. First of all, the majority of calls to the support service can be avoided entirely due to instructions for self-diagnostics and self-debugging. Besides, the operator will know in advance the exact cause of the problem a customer is experiencing. No need to guess, no need to question the customer. The support calls will be much shorter and the amount of calls will go down dramatically. In addition to all that, the reports will solve the diagnostics routine for the support service, will make the work items by technicians transparent, and so on. For the complete list of the advantages of the reports and diagnostics and self-debugging system built on the top of the report, please refer to www.nttechnologies.com.